Hi, and thanks a lot for listening to this tutorial video on panel data analysis. We have a series of 36 countries representing country in sub-Saharan Africa in this Excel file. So we have the first country, which is Benin, which have in the second column the country ID 1. So we have here of observation of different variable, which is from 1970 to 2018. So we have variables such as IMF purchase, PPG, GNI, which stand for gross national income, and the total debt service in percentage of goods and services and primary income. Each country, Benin, for example, Benin, we have one as country ID, and we have observation on Benin through 1970 to 2018. We have the second country, which is Benin, which is Burundi, which have two as country indicator, and we have also data running from 1970 to 2018. So we have other countries such as Burkina Faso, Cameroon, and so on. We have first of all country, which is repeated as much as there are time observation. Thirdly, we have different variables that are correct in data set, and while your data set have been featured like it is in this Excel file, you are now ready to run panel data analysis in EViews. So the first thing to do is to open EViews. Once EViews have been opened, you can close this tab that is open. So just go to import file by clicking on file, import, and click on import from file. After clicking in import from file, you just need to navigate in your computer to go in the folder in which your Excel file is located, and just click on your Excel file and follow the procedure through the last stage and finish your importation. And this tab is open, asking you to link imported series and alpha object to external sources. That's the question. Click on no, and you can see that your variable has been recorded in EViews. So we are now ready to run panel data analysis using EViews. To estimate our panel data analysis, you just need to go to quick and estimate equation. So we select our dependent variable. Here our dependent variable is IMF purchase, following by the explanatory variable. Start with constant C. We have total debt service as first variable. We have GNI, the gross national income. We have PPG. We have at last we have PPG, and that's it about variables. So we have our dependent variable, which is IMF purchase, total debt service. We have GNI and PPG as variable that we are going to use to explain our IMF purchase, to see whether or not debts have impact on IMF purchase. So we go on secondly on panel option. So we just change cross-section, be fixed or random effect model. So if you click on fixed effect, for example, and then click on OK, you will see that our fixed effect model has been estimated, and we have our coefficient, the significant. We have the total debt service, which is statistically significant, and the effect is positive. So the debt have a positive effect on IMF purchase according to our fixed effect model. So we also have PPG, which is significant, which significantly influence the IMF purchase. So the GNI didn't significantly influence IMF purchase, but the sign of GNI on IMF purchase is negative, meaning that if GNI was statistically significant, so the impact would have been negative on IMF purchase. So let us also estimate a random effect model. So we have a random effect model which have almost a different coefficient, significant 5% level. So we can for example, test for make a test specification in order to see whether or not fixed or random effect model is better in this situation. So to make a Haussmann specification test, you need to first of all estimate your random effect model. So if I estimate a fixed effect model and go to view fixed random effect testing and go on Haussmann correlated random effect Haussmann test. So EViews will show me this message to recommend me to estimate a random effect model in order to run Haussmann specification test. So we need to estimate a random effect model first in order to make Haussmann specification test by clicking on view and fixed random effect testing, and finally correlated random effect Haussmann test. So we click on OK, and the result of a Haussmann random test is here, which a p-value of 40%, meaning that our null hypothesis, which is random effect, is a consistent model, is accepted. So rather than estimating a fixed effect model, you should estimate a random effect model. So you can see that our random effect model have a very slow R square, in contrary to our fixed effect model, which have a much higher R square. But our Haussmann specification test show that we should estimate a random effect model in order to better analyze dependence between IMF total debt service and the IMF purchase. So we can, after estimating our random effect model, look for residual testing. For example, see whether or not our residual are normally distributed or not. To do so, we can go on view and click on fix residual diagnostics, and then click on histogram normality test. So you can see the result of our Jack-Berra test, which have a p-value that is almost null, meaning that we accept the null hypothesis, meaning that our error, we reject our null hypothesis, meaning that our null hypothesis is our residual are normally distributed. So we reject our null hypothesis, meaning that our residual are not normally distributed. So we should not use this model to analyze the impact of debt on IMF purchase, because one of hypotheses in which panel data analysis is violated. So we can also look at serial correlation in residual. So we also go on view residual and cross-sectional dependent test, and we can see that we didn't have enough information in order to compute this test. That's because some of the statistic and p-value are unavailable because of the fact that our panel is not very not balanced, and there are many missing data in our panel. Our panel. So have any other possibility of estimating testing for normal distribution of residual, a zero elasticity or serial correlation in our residual. So that's it for this tutorial on panel data analysis.